on via our website. Today, I'm going to talk to you about the problems and possibilities of infrastructure when it comes to stream health. We'll be taking a deeper dive into how the built environment like roadways, impervious surfaces, stormwater and sewer systems, and stream crossings impact the health of our streams, and a little bit about what you can do to improve stream health. My name is Riley Sunday, and I run ACCD's Dirt, Gravel, and Low Volume Road Grant Program and our Nutrient Management Program, which are two topics that'll be woven into this chapter and our Chapter 5 webinar on Tuesday. As a note, if you have any questions throughout the presentation, please drop them into the chat box, and one of our other staff members participating in the webinar today will be keeping track of your questions and will answer them at the end of the presentation. Here is a quick look at the webinars from this series. Today, we are looking at Chapter 4, but it is not too late to register for the next 3 upcoming webinars. This week, you can expect to see an email from me with some links to additional resources from today's presentation. And if you missed any of our other webinars, don't worry, they're going to be available online through our website once the series has concluded. Once the series is over, we're also going to be sending out a link to a survey, which we would really appreciate you completing. By completing the survey, you're helping us to develop better materials for future use in our community. Thank you all for being here with us today, and let's get started. Before we jump in today's topics on problems and possibilities with infrastructure, I want to take just a brief moment to review our previous webinars in this series. We started our journey with Chapter 1, which gave us an introduction to key stream vocabulary and the anatomy of a stream. We also talked about watersheds and how areas of land drain to a single source, such as a stream or lake. We then talked about measuring stream health and how we can use visual, biological, chemical, and physical properties to assess health. Tuesday, we discussed erosion and how it's a natural process, but can be accelerated by human activities, something that will tie in a lot with today's presentation. Accelerated erosion leads to the deposition of sediment in streams, causing problems for stream ecosystems. And finally, it's important to remember that all of these factors tie together and influence one another in a stream system. Today's presentation will have 4 sections. We'll start with just a brief introduction and then move on to infrastructure that impacts stream health being the focus of this webinar series. Next, I'll talk a little bit more in depth about stream crossings. As the program administrator for our Dirt, Gravel, and Low Volume Roads program, stream crossings are a big topic for me and sometimes overlooked in conversations about water health and the built environment. And finally, I'll go over some solutions. But remember, our upcoming webinars that focus on municipal solutions and homeowner solutions will be taking an even deeper dive into modifications we can make to improve stream health. So stay tuned for those upcoming editions. Jumping in, there are about 41,000 miles of roads in Pennsylvania and 86,000 miles of streams. PA is home to the second largest number of stream miles in the US, which makes it clear why so many of our roads end up along streams. Historically, streams were key for navigation across the state, and as networks and pathways became more permanent, many were kept in place along waterways. The same then was true for utilities. Many utilities are gravity-fed, and sending them along the stream made it easy for transportation, maintenance, and access. In our previous webinars, we talked about the nature of streams and how they are dynamic, meaning they change over time. The change in shape and characteristics of a stream is a natural process. But roads and a lot of other infrastructure by design are static, and over time they can come into conflict with the will of a stream. Roads can end up closer to streams and become significantly eroded or even wash out in extreme cases. This creates problems both for road stability, maintenance, and stream health. But let's take a closer look at some of the impacts of infrastructure on stream health. Roads and other infrastructure impact streams in several ways. Over time and with daily use, road conditions can deteriorate over time. As this gradual erosion happens, that sediment can be transported and deposited into streams. Dirt and gravel roads in particular can dump large quantities of road and material into streams, particularly during storm events. I'm going to play this short clip of a dirt and gravel road in our county. This road was part of a Dirt and Gravel Roads grant project. We helped to install some improved drainage features to reduce the impact this road has on the stream parallel to the road surface. If you take a look, you might notice how the water is creating these deep cuts in the road surface. Where do you think that material is going? Now notice when the road surface changes. This change that we see in the clip is where additional drainage methods were incorporated in order to manage the stormwater more effectively. This had two important outcomes. It reduced this road's maintenance and improved its overall functionality, but it also reduced sediment loading and improved stream health in this particular section. There are ways that roads and infrastructure can contribute sedimentation in streams, but they can also be impacted by natural processes of erosion and sedimentation caused by the stream themselves. Remember, streams are constantly changing. As I mentioned, the location of roads in close proximity to streams was very convenient at the time, but now there are plenty of instances where streams are cutting into the road. Here's one photo of a paved road in Allegheny County on the outside bend of a stream. Below the road, we can see how the stream is cutting into the bank and has even exposed an old utility line. If this was an active utility line, it could be a dangerous situation. If the line became damaged, it could also discharge pollutants into the stream itself. Water and infrastructure is all about flow. How is the water moving across the surface and finding its way into streams? These flows of water are often referred to as drainage patterns, which can become disrupted through the installation of infrastructure. For roads, this can mean changing the topography or diverting drainage using berms or ditches that trap water or convey it in concentrated runoff. Concentrated runoff can carry with it road salts, litter, sediment, oil and gas residues, and other pollutants that then enter the stream without any opportunity for treatment beforehand. These pollutants change the stream environment and can harm wildlife. Road salts, for example, can increase the salt content of streams, making them uninhabitable, in some cases, for freshwater fish. This picture is obviously not from around here, but I picked it because you can see how the road is cutting into this natural landscape and could be changing the way water is flowing across this surface. Other infrastructure designs can also alter drainage flows. The first two images here represent changes to surface flow to purposefully concentrate runoff. But as you can see, the water has a mind of its own and has eroded the area around the pipe in this first picture. This second picture shows what a concentrated flow might look like as it enters the stream. These infrastructure designs are made with the human use in mind, but both streams and infrastructure systems tend to have better health and durability when working within the flows of nature. I want to briefly mention before I continue with the problems that arise between streams and infrastructure that the story is not all bad. This third image is a positive one. I wanted to make sure I stuck in here. This was a road drainage project that was part of a low volume road grant, and this project captured stormwater and natural springs that were flooding the road and diverted them into this grassed area, which became a restored wetland. Wetlands are great because they help in protecting water quality and also provide important habitats for wildlife. Another type of drainage interruption is impervious surfaces. It seems pretty obvious that a parking lot would not allow stormwater to infiltrate in the same way that an open field might. But there are additional concerns regarding how water is conveyed from these impervious surfaces into nearby water bodies. With an impervious surface, pollutants and materials carried by water do not have the opportunity to filter before entering the streams and waterways. So we see similar issues with roads and concentrated flow that I mentioned in the previous slides. Take a look at this graphic. Notice how the impervious ecosystem on the right, we have 55% of the water being transported as runoff, versus the situation with natural ground cover where 50% of the water is infiltrating. Imagine the sheer volume of water and the impact it might have when we think about the fact that an inch of rain on just 1 acre of land is 27,154 gallons of water. In addition to interrupting drainage patterns, infrastructure like utility lines can also impact the health of a stream. Utility lines, like roads, are often located beside streams for both convenience and access for maintenance. These lines can cause damage to streams during installation, as well as during routine maintenance because of the disruptions to the habitat and ecosystems while work is being performed. In some cases, damage to utility lines can also cause issues with materials being deposited into the stream. In extreme cases, burst sewer lines can lead to disastrous stream health consequences. But even in more mild cases, damaged utility lines discharge materials into a stream that are not designed to be there. Building infrastructure in and around streams can be tricky business. Some of you may be familiar, but part of the responsibilities at the Conservation District is to make sure that activities that would change, expand, diminish the course, current, or cross-section of a water body are monitored. This happens through our Chapter 105 program, which is delegated to us through the Pennsylvania Department of Environmental Protection. This program focuses on 3 aspects. The first is permitting. ACCD reviews, receives, and approves general permits, which cover specific structures and activities that might impact streams. Some examples include utility crossings, minor road crossings, and fish habitat structures. A person may not construct, operate, maintain, modify, enlarge, or abandon a dam, water obstruction, or encroachment without first obtaining a permit. The second piece of Chapter 105 is inspections. ACCD performs inspections of sites where we have issued permits or if we receive a complaint about a 105 related issue. And thirdly, ACCD works with contractors and the community to provide technical assistance and educate the general public about our programs. This program can be particularly important when it comes to stream crossings, which I'm going to dive into now. Stream crossings are another piece of critical infrastructure that can have a big impact on stream health. Stream crossings have a lot of shapes and sizes, from bridges to small crossings on a driveway. The shape, size, and positioning of these crossings can either work with or work against a stream and impact health. Streams are powerful, so when designing infrastructure that will capture, direct, or be used to cross over a stream, there is a consideration for the ebbs and flows of stream surges. One approach to this has been to think about the velocity and power of a stream and if the water were to shoot through the pipe. This was pretty typical, a typical way that structures were engineered. Designing a stream structure to handle the flow of water considers a stream from an engineered perspective rather than an ecosystem perspective. And as a result, structures that focus on quantity and velocity of water over environmental components of a stream can lead to issues. There are 4 examples I'm going to talk about today that relate to how undersized stream crossings can negatively impact stream health. They are that it disrupts stream continuity, decreases or increases flow speeds, creates ponding, scouring, and erosion, and can cause flooding. Stream continuity is the concept of keeping the stream connected and unbroken. The connection of streams to riparian and upland areas is an important issue for species in aquatic ecosystems. These creatures rely on an ability to move unimpeded both daily and seasonally through streams and nearby areas. This navigation through our streams and river systems requires the ability to find shelter, escape danger, search for food, and maintain genetic diversity. Installing stream crossings can disrupt this continuity in ways that threaten the needed access to a variety of habitated areas. This pipe is a prime example of broken continuity. The angle and the drop of this outlet would be difficult for aquatic species like fish to use this crossing as a point of connection in reaching the resources upstream. Undersized stream crossings can also create a variety of problems associated with flow speeds. Water speeds are higher in constricted crossings than it would be naturally upstream or downstream. The problems with these fluctuations in flow speeds are twofold. First, the high flow conditions can deteriorate the condition and integrity of the crossing. Also, during flooding events, the structure can be filled with this faster moving water, which will exacerbate any deficiencies. Low flow speeds can make passage through a pipe by aquatic organisms nearly impossible. Fish and other aquatic organisms require sufficient water depth to move through a stream crossing. And low flow conditions can lead to stagnant conditions in a crossing, and that can cause bacteria buildup. Ponding at the entrance of a pipe and scouring at the exit and erosion at either end can be another major issue with undersized structures. With an undersized crossing, there's restricted flow entering the structure, and this can cause water to back up upstream of the crossing. This backup is also called ponding and can lead to property damage, road bank erosion, and severe changes in upstream habitat. But ineffective stream flow through a crossing can also cause issues downstream of the structure. Riverbed scour occurs when the shear stress induced on the riverbed by flowing water exceeds the resistance of the channel bed material. This downstream scouring and erosion degrades habitat for fish and other wildlife. Construction or changes in upstream or downstream of a crossing can influence the river flow and channel morphology. High flow velocities in particular can exacerbate erosion. If a crossing is not properly embedded in a stream, this erosion can undercut the structure, which degrades its integrity and also impedes upstream passage. This last issue is one I'm sure folks on this webinar can relate to, and that is clogging and flooding. It's not uncommon for materials such as woody debris and leaves to flow down through a stream. And in more urban areas, there are other treasures we might find. I've seen all kinds of things floating in our rivers and streams like cinder blocks and tires. But the ability for these materials, organic or not, to pass through a stream crossing is pretty important because otherwise the structure can become blocked. This not only limits passage through the structure for organisms, but also can lead to flooding. Everyone hates flooding, and it can contribute to further issues like erosion and sedimentation into streams. So we've looked at these 4 key issues that arise when stream crossings are installed and sized improperly. And the key message to take home from this, from looking at these stream crossings, pipes, and culverts, is that sizing matters. Ensuring that the built and natural environments are not in conflict is important for both human and natural uses of the landscapes. This webinar is about problems, but also possibilities. So let's talk about the ways we can work more effectively within our infrastructure needs to improve stream health. Solutions, if you will. We're going to have 2 webinars, like I mentioned, that focus specifically on homeowner and municipal action points. So I will not go to too much detail, but I wanted to touch on some solutions that homeowners and municipalities can take to improve the relationship between infrastructure and streams. Some general solutions that everyone should be considering how and when we design stream crossings is keeping the ecosystem in mind. So what does this mean? Well, first, we can think about a stream crossing that meets what is called bank full width. Bank full width is the measurement across a stream from bank to bank at the height the water would be during a bank full water flowing event. This is a bit of a complicated concept, but if you find yourself in a situation where you need this measurement, give the Conservation District a call and we can help. Stream crossings should also maintain connectivity and be angled in a way that aligns the stream channel and maintains proper depth. This will improve habitat connectivity and improve the longevity of the crossing. It's also a good idea to use naturally occurring stream bed materials to fill in the inside of the pipe. This allows the ecosystem that's inside the pipe to be as close to the same as the outside. If you're a homeowner and you're looking to replace a small crossing in your driveway or what have you, look to make sure that it is the correct size. But in addition to stream crossing considerations, there are small steps you can take as well. Do things like try to avoid littering along roadways. As we've talked about, improper drainage can cause surface flows to carry that litter into streams. Another simple thing you can do is try to limit your own installation of impervious surfaces. This will help to increase infiltration of stormwater and can create vegetative areas where water can flow through and be treated before entering a stormwater system. You can also use these to help reduce areas of concentrated flow. From a municipal perspective, there are some more things you can do because of your authority to work on and improve infrastructure systems. So one thing that can be done is identify stream crossings that might be undersized and prioritize them for replacement. You can also prioritize drainage improvements to roads that improve the flow of water and decrease concentrated flow and filter contaminants from the roads before entering waterways. In particular, this is super important on roads closest to streams. You can also work to preserve green space, and that's another very simple piece of the puzzle that can make a big impact. You might be thinking this is way easier said than done. Road projects are expensive, especially stream crossings. Well, funny you should be thinking that, because another municipal solution I have here is to ask your local conservation district about the Dirt, Gravel, and Low Volume Road Grant Program. This program funds municipalities to make environmentally sensitive road maintenance improvements along dirt and gravel or paved roads with fewer than 500 cars per day. I can include some more information on this program in my follow-up email if anyone's interested in learning more about this particular funding source. Lastly, It's important to know what you're looking at. Try to become familiar with proper erosion and sediment control measures. These are often installed during road projects near streams and can help reduce negative impacts of sediment deposition into a stream. Ensure stormwater is properly addressed and that runoff is diverted and treated as it exits roadways and before it enters streams. And finally, contact your local watershed group or conservation district to ask about how to further support stream health in your area. I'm going to wrap it up here with 3 take-home messages. So number 1, remember always that streams are dynamic and infrastructure is static, which can create challenges for infrastructure maintenance and stream health. Secondly, infrastructure can negatively impact stream health by changing drainage patterns, leading to increased deposition of sediment and other pollutants. It can alter habitats for stream wildlife, which can have consequences for food sources, shelter, and mating. And finally, consider the needs of a stream ecosystem when designing and implementing infrastructure. Include areas where sediment and stormwater can be filtered through vegetation. Thank you all for listening, and if there are any questions, I'm happy to take those now. Next time, join us as we talk about streams and nutrients, the good, the bad, and what's in between. That will be upcoming this Tuesday, June 16th. And now I will turn it over to my coworker to read out any questions we might have gotten in the chat box during this presentation.
Hey there, Riley. Thanks so much. It looks like we don't have any questions in the chat box, and we'll encourage anybody to get some last-minute questions in if there are any. Now's your time. You can also follow up with a question after the presentation in an email. Okay, looks like we don't have any questions. Riley, thank you. I never thought about roads and streams and utility lines until I started working at the conservation district. So that was really interesting to go through.
Yeah, and thanks everyone for joining us on our webinar today, and look for a follow-up email from me with some additional resources. Enjoy the rest of your Thursday.